Hello, everyone. Welcome back. So today we're going to discuss what's called the binomial theorem. This is a way to actually multiply. When you have a binomial to a power, actually how to multiply that. So first off, somewhere to the right, what I mean by a binomial to a power, okay, is want to find, say something like this, x plus y to the 10th, okay? Now, unfortunately, remember that's not equal to x to the 10th plus y to the 10th. Unfortunately, you can't distribute powers. It'd be nice if you could. It'd make it a lot easier, but you can't. What this does mean is this is x plus y times itself 10 times, which, as you imagine, would take a long time to have to multiply all those out. But there's actually another way someone developed or someone found called the binomial theorem, which allows us to expand it in a much easier way. So first we have to build up to that, and so to get to that point. So our goals for today, understand we're going to use what's called factorial notation, be able to understand what that is, what it means, how to do it, be able to find what we call the binomial coefficients, and then finally use this binomial theorem then to actually expand power of a binomial. So first, let's talk about what's called n factorial, often just simply called a factorial notation. Okay, and here's our definition. So what this says, I'm going to call these often just factorials. What this says is that in this exclamation point, what that means is I take n, multiply it by one less than n, and multiply that by the next number down, next integer down, and then so forth, all the way down to 3 times 2 times 1. So let's take a look at a couple quick examples. And also mention that 1 here, 1 factorial is 1. And actually, strangely, this may seem strange, but actually 0 factorial is defined to be just 1. This is by definition. What that means is essentially that someone decided that. This kind of makes these formulas work. We'll see later on, but that's what that is. So 1 factorial, of course, is just 1 times itself. 2 factorial, then, of course, is 2 times 1, which is 2. 3 factorial, then, is 3 times 2 times 1. So you see what you're doing. We're essentially taking the number, then multiplying it by the next number down, then the next number down until we finally get to 1. This is 6. 4 factorial, then, of course, just 4 times this. 4 times 3 times 2 times 1, oops, which is 24. It was like a 4. And then finally, let's do 5 factorial. You get the idea. So 5 factorial is then, of course, 5 times this. 5 times 4 times 3 times 2 times 1. And that turns out to be 120. So you see these numbers get large quickly. In fact, 10 factorial, or I can try and multiply that out. But a lot of you have your calculators, many calculators, even like iPhone calculators and probably other smartphone calculators will do this. We do 10 factorial, for example. This is a very big number. So 3,628,800. Okay, so that's actually 10 factorial. So you get the idea. So basically, we just take whatever number this is, multiply by the next number down, and times the next number down, all the way back to 1. Right, so that's what factorial notation means. As we'll see, we're going to use factorials and factorial notation in our next topic, which are called binomial coefficients. Remember, coefficients are numbers in front of variables. And so, as we'll see, these are going to be the coefficients in front of these variable terms we'll have when we actually multiply these binomials different powers. So, binomial coefficient, look over here, what this says. If you have non-negative integers, and all these numbers talked about here are integers. Okay, so remember what that means. No fractions that can't reduce to integers, or rational numbers or anything strange like that, no decimals. The way you write this is NCR, and this is actually what's also called a combinational notation, but you may learn that somewhere else. Also, the notation can be written like this: N and R, where you have two numbers N and R. R is smaller than N. And what this means is, as it says, N factorial is equal divided by R factorial times N minus R factorial. Okay, So what we're doing is learning a new notation. So when you recognize this or this, you'll know what that means. Okay. So let's do a few examples, just kind of show how this works. So let's do this one. Let's say we have 5 CR, 5C, sorry, 5C2. Okay. It can also be written like this with a 5, so parentheses with a 5 over the 3, or sorry, 2, I said 2. And now what this means, just follow the pattern. So 5, we have 5 factorial, divided by R, which is 2 factorial, and then times 5 minus 2 factorial. And then that's going to be 5 factorial over 2 factorial times 3 factorial. Okay, so once again, this is the notation for this. Okay, so 5C2 can also be written like this. What this means, we have 5 factorial, the top number, and then down here, the R is our 2. It's R factorial, then finally the other one is 5 minus R factorial, or N minus R factorial. Now this then, if we just simplify and multiply this out, we should just set 5 factorial was 120, 2 factorial was just 2, 3 factorial was 6, and so we have 120 divided by 12, and this is just going to be 10. And that's what that number is. Okay. Let's do a couple more. Let's do this one. So 3C0. Okay, so I actually use a 0 factorial on this one. Once again, the same pattern. So you can see it over here as well. And so with this, we can also write this as our n as our 3, r is 0. And once again, what this means is 3 factorial. Okay, and down here, at the bottom, we have r factorial, which is 0 factorial. And then in parentheses, we have n minus r, 3 minus 0 factorial. Okay, so it's going to be 3 factorial divided by 0 factorial times 3 factorial, because 3, of course, 3 minus 0 is 3. Of course, as we said, then 3 factorial is 6, 0 factorial is 1, it's defined to be 1. That means there's a choice, and then that's why I say it kind of makes this formula work out. And then once again, 3 factorial is 6, and of course, this is just going to be 1. All right, let's do one more, just kind of get the feel for the pattern. What if we do something like this? What if we do 4C4? Okay, or you can also write it as our n is 4. In this case, our r is also 4. Just follow the formula. So on top, we have the top number, 4 factorial. Down here, we have the r, which is also 4 factorial. Then n minus r, 4 minus 4 factorial. Of course, this is going to be 4 factorial over 4 factorial. Of course, 4 minus 4 is 0 factorial. See the 0 factorial again. Of course, this is 24 over 24 times 1. And this is also 1. Okay, and this is also something that's true as well. So this is actually true for any number like this. You can also say that if you have n, you can generalize this and say that nc0, which is this, n over 0 is 1, and also ncn, which is n over n, is also 1. That's true of any n. Okay, so that's what a binomial coefficient is. And now we'll see in here in a moment how we actually use those to help us in these expansions. In fact, I guess that's our next topic. Let's talk about that. Let's go back here to the left. Now, the binomial theorem. Okay. Now, first, let's practice a bit of multiplication. So if we do a couple quick examples, let's just do 1 x plus y squared. Okay. And remember that we can't distribute the power. That's not x squared plus y squared. What this means, of course, is squared means this is x plus y times x plus y. Okay. Now, if you FOIL that out, what you're going to get is x squared plus 2xy plus y squared. You can try that on your own, but if you fold it, that's what you get. Now, what if we also did up 1 power? So we did 2, then that would be x, of course, x plus y cubed. And of course, this would be x plus y times itself. We have 3 of those. Now we can actually use our last result. This is going to be x plus y times, x plus y times x plus y is this, x squared plus 2xy plus y squared. And once again, I'm just going to give you the result, but it's a good idea to try this on. If you distribute the x plus y to each one of those terms, what you're going to get is going to be this. The x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay. Now, those first few are not too bad. Okay. But what if you wanted to do, say, 3? I'm not even call it a 3. Just say, what about x plus y to the 10th? Okay. And at the 10th, that's going to get really tedious. It'll take a long time. So, as I said before, someone discovered a way of doing this called the binomial theorem. All right. Now, I'm not going to rewrite it here. It takes a little while to write, at least in this form. But what this means, and this here, let's come back over to the left, is a general, and so where n is general. Of course, n's got to be like an integer, once again, a positive integer. What this is it going to be, the first term is going to be x to the n. Next term is going to be, once again, this is where the binomial coefficient goes in. The coefficient of, this is nc1, okay, times x to the n minus 1 times y plus another binomial coefficient with n over 2. Then our exponent for our x is n minus 2, n minus the r here, and y is just the bottom number of the r. Then our expression in the middle, anywhere in the middle, of course, they all look like this. N over r, that coefficient, then x to the n minus r comes y to the r. And the second to last one is going to be n, the n minus 1, and finally y to the n. All right? Now, so that can actually be written in a more compact form, as is below. We'll show that. So this is the actual binomial, called binomial theorem expansion. For x plus y to the n. Okay. And what this says, that equals, you can write it more concisely in sum notation, and we'll actually do an example like this. Look what just happened. Sorry about that. There it is. That was bizarre. Okay, let's come back over here. So if we do x plus y to the n, then that's equal to, come back over here, this. So we do a sum notation. So if you've seen, hopefully you've seen this sum notation before, we'll explain it. Let me write it down first and explain what it means. This is called a Greek letter sigma. And then we have our binomial coefficient n over r, and x to the n minus r times y to the r. Okay. Now what this means, anytime you see this big Greek letter sigma, that means you're going to sum. And we're starting here where r is 0 when we go up to n. Okay. And so basically, if you do that, that's what you have right here. Okay, this has been expanded out. So the first term, if r is 0, we have n over r is 0 right here. And so actually this just becomes, we said before, n over 0 is just 1. You'd have n minus 0, which would be n, and then of course y to the 0 is just 1. So actually the y goes away, you're just left with x to the n. Okay, and instead of trying to say all that, we'll actually do an example to kind of show that. And then you start over. So then plus, then where r is 1, put 1 again for r. Okay, find that number, find those values. Then start over again. When r is 3, plug in 3 for r, find everything again. Then we do, so we finally get to when r is n, we stop. So let's actually do the ones we did above, and let's actually show this works, or at least one of the ones. Let's do this one. So x plus y cubed, using this binomial expansion. Okay. We already know what the result is. So x plus y cubed, okay? And so that's equal to the sum of r equals 0 to 3. So n is 3. 3r, so it's replacing all the n's with r's. X to the 3 minus r times y to the r. Okay, so let's write that down. As a good one to start with, it doesn't have too many terms. All right, so the first term, all right, when r is 0, it's going to be binomial coefficient 3 over 0, and x to the 3 minus 0 times y to the 0. That's our first term. Then add that, and when r is 1, we have, replacing all the r's as 1, coefficient 3 over 1, x to the 3 minus 1 times y to the 1. Let's squeeze all these in. And we have 3, 2, make r equals 2. Then we have y to the 3, or x to the 3 minus 2, not y first. X to the 3 minus 2 times y 2. And finally, plus 3 over 3 when r is 3. This is where we're going to stop, be our last term. This tells us where to stop. X to the 3 minus 3. Sorry, I'm trouble writing numbers sometimes. 3 minus 3 times y. It should be an x. Times y cubed. Okay. Now, let's go through and figure those out. Let's do a few things first before we actually go to it. So let's think about our coefficients. So 3, 0, we said a minute ago. Look back in our notes, we said that generally, in general, any number over 0 is 1. And also, any number itself is also 1. We do the coefficients. So 3 over 0 is also the same as 3 over 3. Those are equal to 1. Let's do 3, 1. 3 over 1. Okay, so remember how that works. It's going to be 3 factorial over 1 factorial times 3 minus 1 factorial. It's going to be 3 factorial over 1 factorial times 2 factorial. That's going to be 6 over 1 times 2, which is 3. Okay, and then if we do 3, 2, same pattern. The top numbers are going to be 3 factorial, or n. It's our n. And here's our r. We have the r factorial, or 2 factorial. Then n minus r, 3 minus 2 factorial. We'll see, it turns out that's exactly the same thing as 3 over 1. So this is 3 factorial over 2 factorial times 3 minus 2 is 1 factorial. And that's going to be 6 over 2 times 1, which is also 3. So now we know what our coefficients are. We have 1, this one is 1, this one is 1, this one is 3, this one is 3. Okay, so let's actually go here. Let's say, so x plus y cubed is equal to, so once again, this is 1. Of course, x to the 3 minus 0 is x cubed. Y to the 0 is 1, so the first term is just x cubed. We said that 3 minus 1 factorial, or 3 minus 1, that coefficient is 3. Plus 3 is x to the 3 minus 1, x squared, times y to the first, or just y. Plus again, we said 3 over 2, that coefficient, is also 3. Once again here, x to the 3 minus 2, that's x to the first, or just x. We're saying y squared. And then finally, 3 over 3, coefficient is 1. X to the 3 minus 3. 3 minus 3 is 0. The x to 0, which is 1. Then it's just y cubed. Okay, if you'll check, we look again, that's exactly the same thing we had before. This allows us to do this without having to actually multiply them all out by hand. That's exactly the same thing we had. Okay. Okay. So that's how the binomial, this is a quick example of how the binomial theorem works. Now, I'll also mention one more thing over here. If we have one with a negative instead of a positive, whatever we're going to think about that is the thing is it's x plus and make the y negative and negative y. So x minus y is the same as x plus negative y. Essentially replace the y here with a negative y. Okay, and that will make our signs correctly because when r is positive or r is even, of course, any negative square, any negative to the even power is positive. Any negative number to an odd power is negative. So that will get the signs correct. Everything else will work exactly the same. So let's do one more of these. We'll do one with a negative, see how it works. So that was number 1. Let's go to number 2. Let's do (4a) minus 5b to the 5th. Okay. Now, here, a couple of things to notice in our formula. Right here, we have our x is the same as 4a, and our y is 5b. Okay, so that's where we plug those in. We're also using this one right here because it's negative. Let's see how that works. Okay, so this is going to be equal to, so we have the first one, we're going to have, since it's up to 5, and so this is going to be the sum of r equals 0 to 5, since our n is 5, our power is 5, and that's going to be 5 over r as our coefficient. Then our x, which is 4a to the n minus r, times our y, which is going to be negative, so include the negative or negative 5b to the r. Okay, so just plugging in everything we have, we kind of make a new formula. Okay, so now we just start. So start at 0, replace our r's with zeros. So we have 5, 0. We have 4a to the n, sorry, the n should be a 5. Missed that one. So 5 minus 0 times negative 5b to the 0. Okay, that's our first term. Let's do our second one here. So add the repeat, start now, r is 1. So 5 over 1. We have 4a times the 5 minus 1 times negative 5b to the 1. Okay, plus, then start over, r is 2, 5 over 2. Then once again, we have 4a to the 5 minus 2 times negative 5b squared, plus, then r is 3, get the idea, 5 over 3. And so then we have 4a to the 5 minus 3, then times negative 5b cubed. All right, a couple more. And repeat, once again, r is 4. And so we have 5 over 4 times 4a to the 5 minus 4 is negative 5b squared, negative 4th to the 4th, rather. Okay, and then once again, r is 5. This is where we'll stop here, our last one. And so we have 5 over 5 for our coefficient, then 4a to the 5 minus 5 times negative 5b to the 5th. Okay, so we have 6 terms. So once again, we already know, let's look at our coefficients again first. Well, it doesn't matter. So once again, we know that 5 over 0 is equal to 5 over 5, which are 1. So the first and the last one are 1. Okay, let's also do the other one. So we have a 5 and a 1. 5 over 1 is going to be 5 factorial over 1 factorial times 5 minus 1 factorial. That's going to be 5 factorial over 1 factorial times 4 factorial. And that's going to be 120 over 1 times 24, and that should be 5. Okay. Now, 5 over 2, same idea. So 5 factorial over 2 factorial times 5 minus 2 factorial. And so that's 5 factorial over 2 factorial times 3 factorial. So that's going to be 120 over 2 times 6. And so that's 120 over 12, and that's going to be 10. And then 5 over 3 factorial. And I believe this is going to be the same thing. So 5 factorial over 3 factorial, then 5 minus 3 factorial. And it's going to be 5 factorial over 3 factorial times 2 factorial. My 3 looks a bit better there. Right, no need to go through the details. That's also, once again, 10. It's the same thing. And then 5 over 4 factorial. And that's going to be 5 factorial over, I think it's going to be the same as over 1 factorial. 4 factorial times 5 minus 4 factorial, as it will be. So 5 factorial over 4 factorial times 1 factorial. Same thing we had there, which is 5. Okay, good. So now we know our coefficients. So let's start to work with everything. So the first term, our coefficient is 1. And we have 4a to the 5th. We say, so 4a minus 5b to the 5th, okay, is going to be, the first, of course, the coefficient is 1. And we have 4a to the 5th. And then, of course, negative 5b to 0 is just 1. And so this is just going to be 4 times a to the 5th. Okay. Then either plus or minus, maybe minus for our next term. 5 over 1 factorial, we said it was 5. And then we have 4a to the 4th times negative 5b. So negative 5b to the 1st. So it's going to end up being negative. Let's go and put it as a plus. We'll take care of the negative in a minute. So we have 5, then 4a to the 4th times negative 5b. Okay. Then plus the next one. A little tedious, but still better than, actually could be better than trying to multiply them out by hand. Okay, 5 over 2, that coefficient, was 10. And then we're going to have 4a to the third. And then you should have negative, it should be negative 5b squared. Right? So negative 5b squared. Okay, all right. And we have 3 more terms. So the third one, and coefficient 5 over 3 is the same as 5 over 2. It's 10. And then that's going to be 4. You can see the pattern now, especially 4a to the 4th. 4a squared. This reduces 1. This goes up by 1. So negative 5b cubed plus, and the last 2. So the 5 over 4 coefficient was the same as 5. Then it's going to be 4a to the 4th, or sorry, the 1st. Also the 1st, include the 1st there, 1 there if you want. And then it's going to be negative 5b to the 4th. All right, we're almost there. Okay. All right, last term. Of course, the last coefficient is 1. This is 4a to the fifth. That's going to be 4 to the 0. So that term's going to go away. It's going to be 1. You have negative 5b to the fifth. The last term then is just going to be negative 5b to the fifth. Okay, I'm getting closer. Still, this still can take a while to do, as you see, but still it's not as bad as if I do it all by hand. Okay. Now, as you can see, what we have here is everything multiplied together and all the coefficients correct. Now, let's do a few more things. Let's go ahead and find these rest of these coefficients. So what we're going to have is going to be 4 to the fifth. And that's actually going to be 1,024 times a to the fifth. Okay. This is going to be minus. I have a 1 to the minus. So we're going to have, it's going to be 4 to the fourth. So we're going to have, it's going to be a minus. It'll be 4 to the fourth. Times 5 times another 5. So see, we're doing 4 to the fourth times 5 times 5. Okay. That's going to be times 25. And that's going to be minus 66,400. Times a to the fourth times b. Okay, that's our second term. Let's just patiently, for some reason, I have a hard time writing these numbers today on my keypad, my pad. Okay, here we'd have 4 cubed times 10 times, and here this is going to be times 25. So just keep track of these. It's going to be 4 cubed, 4 times 4 to the third is 4 cubed. Then times 10. Then, of course, negative 5 squared is times 25, positive 25. This term's going to be positive. And that should be 16,000. And then we're going to have a cubed, b squared. Okay. Then the last 3. Okay. So this time we're going to have 4 squared, which is 16. 4 to the second is 16 times 10. And then times negative 5. So actually this can be a negative. So negative 5 cubed, let's make this term here a negative, not a positive. And that's going to be times 5 cubed, which is 125. Okay, hang on just a minute. Let's see if that's right. Try that again. Okay, and this should be 20,000. Okay, and then our powers, we're going to have a squared and b cubed. All right, we're almost there. So here, this one, and of course, this time where our negatives going to be to the fourth power, this is going to be a positive. So we're going to have 5 times 4, which of course is 20, times negative 5 to the fourth. So let's do 5 to the fourth. 5 raised to the fourth is 625 times 20 is equal to plus 12,500. All right, and then our powers are a to the first and b to the fourth. All right, and we're almost there. So finally we have negative 5 to the fifth. So this, a negative to an odd power is negative. So negative and then 5 raised to the fifth is minus 3,125 times b to the fifth. Okay, so that's our result. Okay, now still a bit of a pain, but it takes a while to write out. Okay, now let's do one more thing. So let's say in some cases you don't want exactly the entire expansion. Let's say you just want one term. So here, let's talk about what it says below. So that what's called the kth term of the binomial expansion. Okay, that's what this says over here. So the kth term of the binomial expansion. So, and this is, let's go and rewrite this. So once again, 4, as long as n, the power, is bigger than k minus 1, we can do this. And so the kth term is, remember, this is not a sum, it's just an individual term. This is going to be n over k minus 1 times x to the n minus, parentheses, k minus 1 times y to the k minus 1. Okay, now let's see how that works. Let's say I want to find, doing a quick example, find the third term, or the one we just did, okay, of 4a minus 5b to the fifth, okay? So do the one we just did, okay? So k is equal to 3. First off, let's check. So we have our n is equal to 5. So we have 5 is greater than 3 minus 2. Okay, that's correct. That's true. Okay, so we can do this. All right. So we're going to have, and let's see it over here. It's going to be 5 to the over 3 minus 1. Sorry, k was 1. Then x to the n minus, actually, let's do this. Well, that's fine. Let's keep doing it this way. That's minus 3 minus 1 times y to the 3 minus 1. Okay, so just replacing everything here, what we know. N is 5, k is 3. Okay, we can simplify this. Of course, that's going to be 5 over 2. And then our exponent is going to be 5. Oops, I should replace the n with 5. That's going to be 5 minus 2. The y, 3 minus 1 is squared. And so this is going to be, the coefficient is 5 over 2. And then it's going to be x cubed y squared. Now, let's double check that. Now we know from above, I'll just say from above, 5 over 2, I think was it 10. Okay, 5 over 2 is 10. And also remember, we said that 4x was equal to 4a, and y was equal to negative 5b. So what we have then is that this, the kth term, 5 over 2, so once again, the third term, 5 over 2, that's going to be 4a cubed times negative 5b squared. Of course, we're going to replace this now. This is now 10. Okay. And then once again, if we go through the same thing we did a minute ago, and that's going to be 4 cubed, 64 times 10. Then, of course, negative 5 squared is positive 25. And that should be 16,000. It's going to be positive. And then we're going to have a cubed b squared. And if we compare that to the third term above, now here, also remember the third term, here what we mean by the third term, okay? All right, so the third term, okay? And yeah, that's correct. So our third term, 16,000 a cubed b squared. Okay, and we got, yeah, so this agrees. So this is the same as third term above. Okay, so sometimes you may just want to find one particular term and don't want to find the entire expansion. Okay, let's review what we've learned so far today. So we learned how to use factorial notation, what it means, how to calculate it. And once again, most modern calculators, even like your smartphone calculator, will have that available. They learned also how to do that. Learn how to find the binomial coefficient. Learn two different kind of notations: the NCR notation, also this N over R notation. Understand what it means. Then we learned about the binomial theorem, how to write something like x plus y to the n power, and what is this whatever power we want. And learn how that expansion works. Learn how to write it in kind of the summary notation. Also learned if you have it's actually n minus y to the nth, as you saw, replace the y with a negative y and just plug that into expansion. And then finally found out how to find the kth or the specific term of the expansion if you don't want the entire expansion. So that's how to use the binomial theorem to expand the power of a binomial. Thank you. Have a good day.